We are now on question number 12 from exercise 9.3, chapter circle, class 9th. In this question, we are supposed to prove that there is a cyclic parallelogram and we need to prove this parallelogram or cyclic parallelogram as a rectangle. So the very first thing that we will do is to make a circle and then a rectangle inside it. That means rectangle should be made in such a way that its boundary touches the circle, right? So as this becomes a rectangle, it looks like a should look like a rectangle because we have to prove this a rectangle, although we'll be considering this as a parallelogram. So in the given part, you don't have to do anything. Just simply write that ABCD is a cyclic parallelogram. And in the to prove, you'll be writing to prove ABCD a rectangle. So we'll begin with using the property of a parallelogram. You can say angle A is equal to angle C, and the reason is opposite angles of parallelogram. As you should know that opposite angles of parallelogram are equal. Further, since it is a cyclic, therefore angle A plus angle C should be equal to 180 degree. And the reason for this is opposite angles of cyclic quadrilateral. So these are the two reasons you should give for these two steps. Now look into this. What we can see here that we have angle A is equal to angle C. So I can replace either A with C or C with A. So I replaced C with A, that is equal to 180 degrees. So what I did, the angle C, I replaced it with angle A, right? As A and C are equal from this equation 1. From this equation 1, they're equal. Now, further you can see that angle A plus angle A is twice angle A, that is equal to 180 degree. So angle A is equal to 90 degree. So we have proved one of its angle as 90 degree. As you must be knowing that a parallelogram whose one angle is 90 degree is a rectangle. So therefore we'll simply write, therefore ABCD is a rectangle. And the reason you'll write that a parallelogram whose one angle is 90 degree, right? Since it is a parallelogram, so a parallelogram whose one angle 90 degree is a rectangle. That is what the proof part of this question